Right. Assalamu alaikum. Good evening to you all. My name is Sharaf Ameer, and currently I'm working in a school as a advanced chemistry teacher. And right now, I'm just continued certain classes for 2025 batch here, and now proceeding for yours as 2025 batch and repeaters. Okay. I think this week or the last week you might have received your results. Some of you are happy with your results. The more you dedicated, most of you are happy, but some of you are still aren't satisfied with your results, right? So thinking of that part, so I was too in that situation. So finally I made up my mind to help you all guys out to score the maximum marks out of this subject so that you can ace your Z scores and the merit ranks and the island ranks, inshallah. So that is my target right now. So nothing much to talk. Give me a minute. Right. Uh, Nothing to talk much. Actually, now we are running out of time. So let's make use of this session, right? Inshallah, you will see a huge change. So let's break through this unit because most of you are actually getting stuck in these units, like mostly, like according to my experience, in my point of view of teaching. So I have seen so many students struggling with kinetical chemistry and sometimes physics. And physics is actually easy, but sometimes they get into a lot of trouble. Like, what is the concept going on behind it? So there are lots of things going on within the resource book, and there is some experiments also that you have to deal with. So all those parts are actually very much important as long as these are under physical chemistry. So physical chemistry is the main part in your chemistry part. So around fourth unit, fifth unit, and then you have the 11th, 12th, 13th. So these 5 units and including the general chemistry also. So all these play a major role in the MCQs, structures and essays. So in the case of kinetical chemistry, you should know there are going to be MCQs. Obviously, there are going to be MCQs. Mostly, they will come at the last parts of the pages of the resource book, and they are giving it very specifically that you need to follow up with the resource book. So that is the main part. So without the guidance of these parts, some of the teachers, what do they do is they go on with their own pathway. That's what I have experienced. So in order to avoid such kind of bloody hell circumstances, I'm ready to do a perfect class for you all so that there will be a life-changing perspective in your results, inshallah. So that is my main target. So my main part is to break all the concepts into a small bullet point form. So I have just recently, I think today only, I just started to analyze all the MCQs regarding the kinetic chemistry. So it's actually, you can overcome it. So once you know how to break through it, you can overcome it very well, inshallah. So let's not waste more time. So let's go into the unit. Okay, now we are going to start about the unit. We'll see the unit of kinetics, right? So my dear students, before going into the chapter, using your O-level knowledge of the recent or knowledge that you have, just tell me, what do you mean by kinetics? Any idea? Any ideas do you have, my dear? What is your idea regarding kinetics? If you respond, then only we will know that you are in the class. At the same time, we can understand that whether you are trying to catch up with the point or not. So that's what I'm asking certain questions. So you can be vigilant in the class at the same time and you can study a lot. So whatever happens, don't care whether you make mistakes or not. Me as a teacher or sir, we are ready to correct it all. That is our main duty. So that is not an issue. So you can just give a normal answer like what idea do you have regarding kinetic and chemistry? Still no responses. Okay. Okay, no problem. Right. I think some of you still, I think still you didn't have the clear idea. I think so. Is it so? I think you didn't have a clear idea yet. That's what I think so. Okay, no problem. So the thing is kinetical chemistry, kinetics, chemical kinetics is mostly usually about you're going to talk about the speed of the reaction, and using the speed, there are certain factors that can affect the rate, that can affect the reaction. So once you start to go through the kinetics, so there is a part in the university also that you will say kinetical chemistry. So there's another degree. The main purpose of kinetics is actually, my dear children, it is about finding the reaction mechanism. That's the main part. Finding the reaction mechanism is the main part for the kinetical chemistry. So at the same time, once you know the reaction mechanism, you know the another pathway where you can accelerate. For example, once you're doing industries, let's say in industrial chemistry, there are lots of parts. In the industries, right? Industries, you will know how can we accelerate, how can we proceed these kind of reaction mechanisms that we have. So you can increase the yield of the product and as well as the major parts of this area, right? So that is the main thing that you have to know, right? Within these cases, so let's go through. See here. So first and foremost, you need to know, before going to organic chemistry, you need to know what are the types of reactions that we have. You need to know what are the types of reactions that we have. So within the types of reaction, we have actually three types, right? So we have very slow, moderate, and very fast. So we have reactions of three types, right? We have reactions of three types. One is very slow. Another one is moderate. Another one is very fast. So there are three types of reactions going on, right? Within these three, you should know what are the examples that can be most possibly that can come. So in very slow, you know, rusting of iron can be an example for you. Rusting of iron, it's a very slow process. You all guys know, but you will experience, right? Within your day-to-day life, if you learn chemistry, you can understand the concept. So it's not that much hard, right? Just it's very easy, right? In the case of very fast, right? It takes split seconds. So some of the boys know what the split second means. Like it's like this. So once you know regarding the formula races and all, right? They have split second plus or minus. So it is regarding that much of the second. Like it is a fraction of second. So within a fraction of second, most of them are actually 10 to the power minus 14 to 10 to the power minus 16. So their range of seconds is in this range. Very quick. So as a result, the rate of reaction is very hard, right? You cannot find the rate of this reaction. In this case, once you go through, there are precipitate forming reactions and ionic reactions. These people are actually really fast. The most slow one is the rusting of iron. Also, once you consider moderate reactions, that also is happening in our day-to-day life. You know, decomposition of hydrogen peroxide. So, decomposition of hydrogen peroxide is actually a very moderate reaction. So, it decomposes at a room temperature. Once you expose it, you will get water, liquid, and as well as, let this be aqueous, right? And you will get an oxygen gas. So, this is moderate. I think that same thing. Once you consider about N2O5, so dinitrogen pentoxide. So this is a gas. You are going to decompose it. So once you decompose it, at the room temperature, you will get NO2 plus N2O3. A very simple reaction. Nothing hard here. Right? So it's very easy. So I am breaking it down. So you will understand what is happening here. So these are the types of reactions that we have. After this, you should know why we can't consider this reaction and these reactions. They can ask in the MCQ. Most of the students, they tend to neglect certain areas. There are chances, Puta. Because in resource book, they can ask specifically certain areas. Some areas they can ask deeper. They can even ask you in the exam hall also. What are the examples? Maybe they can ask. So don't worry. Okay. So we don't know how are they going to take the question papers. Okay. So in this case, the time period is very much high. So finding the rate for this is really difficult. In the case of very fast, it is another different case. Right? In very fast, it's another different case. So keeping in this perspective, once you start digging them up, these you should have a very complex instruments to find this up, including this also. So, but in the case of moderate reaction, you can actually calculate using the special kind of instruments that we have. You can do it. In the case of decomposition of this guy, you can use the color change over here. And in the case of decomposition of hydrogen peroxide, you can use the oxygen. So you can find out their rates within a respective time. So you can find out their volume. Here you can find out the intensity of the color change intensity of this decomposition. So it's a very simple idea. Most of the students, what do they do is, they think this is complex, right? This is easy actually. Now come on, right? Let's break it up, right? Right. Now see here, let's consider a reaction, right? Let's say A goes to B. All of these are gases. Let's say there was certain amount. Let's say N. Let this be in A, the amount formed, let it be in B. Once you consider a graph, right? Let's consider N as the amount of A initially, and let NB be the amount of B formed. This is initially formed. This was finally formed. Right? You will understand why I took that case. So if I draw a graph with respect to amount and the time, so you know the graph will go in this manner. So it goes deeper and then the slope decreases. Here, if you go with the mirror type, it goes in this way. So it drastically increases. So here you have moles of A, the amount of A N amount of B. So once you consider the term amount of A means the number of moles. So amount of substance. We usually express them as moles, right? We express them as moles. Here we consider them as moles of B gas, right? So don't worry, everything is easy here. So now this is moles, right? So let's say the initial point, right? Let's say I'm considering this point, and here at this point, you know, in maths, there's a very easy part. Once you need to find a gradient, you know, even in physics also it comes. What you do is take this point, draw a parallel line, draw a line parallel to the x-axis, same way over here, draw a tangent along this slope and along the slope, right? And then connect them up, forming a triangle. And within this range, find another time. So let's say this is T1, let's say this is T2, and this is T1. And from this point, let's say this is the change in NP, and let's say this is the change in NA, right? So you know there is a mole change, right? There is going to be a mole change, but keep in mind, whenever there is a mole change, you're going to find out the change, right? You're going to find the change with the time. Any change that is with respect to time, if you calculate them with respect to time, you should know that we call them as rates. So the term rates came in this way. So this is how I decode, right? So that's what it made me easy. So anything, whatever the rates is, so rate of volume change, rate of surface area change, everything will come divided by the time. So whatever it happens, it comes with time. So rates, in a sense, let's say rate, so it means change with respect to the time taken. So since I'm considering the amount of substance, which means moles. So once I'm considering moles, in this case, here I can say the change in Na over time. So what's my time taken? T2 minus T1. But once I elaborate this, if I elaborate this one, so delta Na can be like this. So it says the initial final moles of A minus initial moles of A. Now you will know why we need to put minus. Why we need to put minus for the reactant side, why we need to put a plus for the product side. The reason is, normally when you consider a total time lapse for the reactants, from the initial to final, the number of moles will decrease. You know from the chemical calculation itself. For the reaction side, the number of moles will decrease. That is the main part. But in the case of products, with the time, so initially it is actually 0. But once the time increases, the final moles will also increase. So if it increases to a time, if you take this one to an arbitrary time, arbitrary means at that instant. It means at that instant. If you consider that kind of case, you know that final moles of A is actually smaller than the initial moles of A. So which means you are going to get a negative value. And if you are going to get this negative value, and if you put over here, it's wrong. Because rates are actually calculated in positive value. They haven't given such kind of explanation in the resource book, okay? So I have given you a detailed explanation. Since the final number of moles of A is less than initial moles of A, the value is going to be less. Since this is less, the rate is going to be in minus. So as a result, you have to consider the change of A with respect to the time taken along with minus. Then only you can get the rate for the change of A, rate of reaction with respect to A in a positive value, because rates cannot be expressed in negative value. So this is the main thing. The rate is being formed as a negative value on this case. Same case on the opposite side. If you consider rate of B, so the final moles of B is actually greater than the initial moles of B. Let's say it is 0 and here it is 10. So this is having a greater value. So finally, you will get a plus value delta A over delta T. So this is in the case of gas, and I have just spoken in terms of amount of substances. So I have just talked with the amount of substances. Now, if I consider this particular reaction taking place within a container, now this is the game. Now this is the game. See here, if I consider this within a volume, within a persistent volume, where the volume is constant, it doesn't change. There, now what you have to do is, now you have to consider with respect to the volume. So, what is the relationship between the moles, volume, and concentration? So, you have three things here. So, you have concentration, moles, and volume. So, if you divide these people, if you divide this amount by 1 over V, if you multiply this one by 1 over V and 1 over V over here, obviously, you're going to get an answer with respect to the concentration of A. So, you will get concentration of A, the change in concentration of A with respect to T. Same case over here, in the case of B, you're going to get the change in concentration of B over the time taken in plus value. Here it's going to be negative value. Understood? So rate means it depends, it says the change with the time. In the case of chemical reaction, mostly you have to say with respect to the concentration. Because according to your syllabus, we are not going to speak about the solid gas interface or the liquid gas interface. You're mostly going to speak about the gas and gas interface in the kinetics unit. That's what, according to the past paper analysis, they can ask with respect to the factors. That is another thing. So nothing to worry. It's a very easy thing. They can ask even for aqueous and aqueous. They can ask in liquid forms also. So that is also not a problem. I hope you guys understood this thing. Okay. Now you said we can find all these things in this way. Okay. Now we found out all these things in way. Now this is theory, right? Now this is theory. Now, if I go with the same reaction over here, with the same reaction, let us suppose if the same reaction, let's say if 2 moles of A gas reacts to form 1 mole of B gas, then it's another stuff. So in this case, once you speak about the initial rate and all, right? Once you consider the rate for A, so it's going to be minus, right? Here you have to keep in mind, the rate is going to be twice. You know why? Because we need 2 moles. Here for 1 mole, we consider in this way. So the rate of this reaction with respect to A, because the consumption of A is twice than of B. B is actually 1 mole. It's forming 1 mole. But in the case of A, it has to consume 2 to produce 1 mole of B. Did you understand? Right. So this is the main thing that you have to know. So this is the thing that is happening here. So the rate is going to be twice than the B. So if I write it with respect to A, right? If I write it with respect to A, so since it is reaction, this is a reactant, this is going to be negative side. So the sign will be negative because you know the reactant's concentration change is actually different of yours. As a result, you have to keep it in positive value, so rate has to be positive. So change in A's concentration over the delta T is equal to rate into 2. Is equal to rate into 2. So if you want to find the rate of reaction with respect to the decomposition of A or destruction of A or consumption of A, the answer is going to be 2 times of the rate, because the rate is going to be twice because of the consumption of A. Here you need 2 moles. So as a result, if you want to find the rate of the reaction for the whole system, the rate is going to be equal to minus 1 over 2 delta A change over delta T. A change over delta T. So this is the main part, the very easy part. So this is how this system came. So finally what did they do is, they gave you an equation in the resource book. Rate is equal to 1 over Vj, right, into the concentration change over the time taken. But now let's consider, see here, a small thing. Let's go deep. This Vj, this value, actually what does it speak is actually, here, wait a minute, you guys can't see, right? Sorry. Now let's go here. So rate is equal to 1 over Vj, change in the concentration of the reactant or product with respect to the time change. Here this Vj depicts upon the plus or minus sign. The reason is, if it is a reactant, you should have a minus value because the rate has to be positive. In the case of B, since it's a product, you have to put a plus value. Right? The change is going to be plus or minus negatively. So that's why we use the term Ej. Understood? So that is the main reason. Now, going through this rate, there are lots of questions, right? There are lots of example questions also in the resource book, right? Nothing to worry. If you practice those itself, it's nothing, right? It's nothing, right? There is nothing in it. But let's dig into the past paper MCQs, right? I'm directly jumping into the past paper MCQs. Okay. Now let's take 2015 MCQ. Since I'm using Pesuru, they haven't given the MCQ number. So let's see in another book. So spare me some time. All right. So 2015 18 MCQ. Right. Select the answers with correct relationship for the rate of reaction given below. So 2 moles of MnO4 minus plus 5 moles of C2O42 minus plus 16H plus will give 2Mn2 plus 5 CO2 plus 8 H2O. So this is the reaction that they have given. Now the question is, they are asking to give the correct relationship. So now they have given all the answers in terms of the change in manganese, manganate and oxalate. You know, once you're trying to write a rate of reaction, let's say if you are going to write the rate of reaction, for example, right? Before going into this question, let me give a broad idea. Let's say you are having A moles of A, B moles of B, which is forming to give C moles of C and D moles of D. Let's say this is the case. Let's say now this is the case. Now see here, as I said you, according to the equation, so rate of the reaction is equal to This is a reactant. So as a result, 1 over A minus 1 over A with a change of A's concentration with respect to the time will be equal to the same thing here. Minus 1 over B with the change with the B with respect to the time t will be equal to, with this case, 1 over C with change with the C along with the time t, which is equal to 1 over D with the change of D over delta t. So this is the case over here. So this is how you have to write the rate of reaction. So this is the easiest way, right? So according to that one, they are saying the rate of reaction should be written in this way. Okay, so this is how you have to write the rate of the reaction. But what if they ask the rate of consumption of A? So let's say if the rate is R, okay, and now they're asking, now I'm elaborating, okay. So if I elaborate, then only you can get the concept here. So don't just rush into the answer. Try to break the question into several parts so you can get broad knowledge. So let's say this is the rate. So R is equal to, in this case, 1 over A. Let's neglect this minus. There's a reason, I'll say you. A delta A is over delta T. Now they're asking rate of decomposition of A. Most of you will say the rate of decomposition of A is this one, no sir, this whole system, right? It's actually wrong. Why? The rate of consumption of A is actually this thing. It has to be this, not the whole system. This whole system will refer to the rate of the reaction, the total system's reaction. This is actually theoretically, right? Still, we didn't go practically. So this is actually theory. Practical it is different. Even in industrial chemistry, we will know. According to different stoichiometric ratios, there will be different things here. Now see here, right? Now see here. Here 1 over A is here. Now this is the rate. This is the thing, right? Minus 1 over A. So this is the rate of reaction. Here a change is there. The change will be in minus value. So as a result, here you will get a plus value. There will be a plus value. Now, here you have A. Now you're asking, the question you're asking is rate of decomposition of A. Neglect this minus and cross multiply to the other side. That's the answer. So rate of consumption or destruction of A is actually 8 times the rate. Is actually 8 times the rate. 8 times the rate. So this is the thing. For the rate of consumption of A, you have to consider the stoichiometric ratio. So you have to multiply directly by the stoichiometric ratio. The short method for this is actually, whenever you get this kind of question, keep in mind, for the MCQs, not for the structure and essay, you have to show. In this case, whatever you have, right? Let's say if you have a stoichiometric ratio, let's say if they have given you a rate R is equal to 8 into 10 to the power minus 9 mole decimeter minus 3 second minus 1. And let's say the A value is actually 2. Then what you have to do? If they are asking the rate of consumption of A, for example, so directly multiply the stoichiometric ratio with this. So you get 2 into 8 into 10 to the power minus 9 mole capital M S minus 1. Okay. Answer is going to be 16 into 10 to the power minus 9 M S minus 1. So capital M S minus 1, because I have just considered this one as capital M, which is mole decimeter minus 3. You can write that one in that manner also. Right. So this is the way. Okay. So the unit of rate is also known to be mole decimeter minus 3 second minus 1. Why? The rate unit can be identified by what is the value over here? Here you're going to have a concentration change. So mole decimeter minus 3. Over here you're going to divide it by time. So the change in concentration over time means Mole decimeter minus 3, second minus 1. So this is the thing that you have to know. Okay. And now to the deeper part. Okay. Now you need to do this question. Now they have given you like this kind of question. Now you are either puzzled to write. So let's say you are in tension. Let's say you are under tension or under pressure or stress during the exam. See here, my dear students. See the question very carefully. 18th one. Some of you, out of hurry, you might put the stoichiometric ratio in different way. So you guys will say, you will take the mole ratios like this. So let's say the concentration of A with respect to, let's say, concentration of Mn over minus with time, right? Over concentration of C2 over 2 minus over T is equal to 2:5 ratio. You will put in this manner and also you can get the answer. This is human mistake. This is actually an error. But once you consider this question, once I say rate of reaction, you should get the idea of this. Understood? I'm just doing a revision, right? And I'm trying to show you how to solve the questions. That's all. If you know how to solve the question, at the same time, if you learn what I teach, what I do with the theory, you can understand what is happening here, right? So it is very easy. Don't puzzle up, right? Don't be in a hurry. Most of you guys are hurry actually. I don't know why. During the exam, most of you lose marks due to silly mistakes. Most of you can go for doctors and engineers. The problem is you guys are actually in hurry. So that is the main problem. Otherwise, you guys are doctors and engineers. Don't be in a hurry. Be patient. Right. Now, let's come to this question. So this is the thing you will do and you will get the answer wrong. So there's that answer is also there. Okay. Now come here. Come to this question. So now they're asking the rate of reaction with respect to Mn over minus and C2 over 2 minus. So oxalate and manganate. Right. Now, right for this. So the rate is 1 over Vj minus thing. So since this is a reactant minus half, change in the M1 over minus over the time change is actually equal to minus 1 over 5. Minus 1 over 5. Change in C2 over 2 minus over the time change. Now they are going to consider Mn over minus, decomposition Mn over 2 minus, Mn over minus with respect to oxalate. So what you're going to do is you're going to equate this up. Once doing equation, you know, minus, when minus is there on the other side, both of the minus can be neglected. So as a result, the answer you're going to get is delta Mn over minus change over delta T, which is equal to 2 over 5 change in the concentration of oxalate over change in time. Right.